All right, so here is ACT test number 2, problem number 58. The first thing to recognize about this problem is that it is a monstrous beast of a problem, and it is important just to say, I see you. I respect you, problem. You may make me want to hate myself and just hate all of humanity forever, but I respect that in you. Okay, so the first thing to do, I guess the second thing to do is just to, recognize what you're being asked to solve for, go through our usual 4 steps, and they want you to find the length of this sort of thing. This makes me freak out. You had asked whether this was a trig problem or whether it's just a really hard geometry problem. I'd say it's at the overlap of both of those things, where it's not like hard trig. Sometimes people will say, what you should do with trig problems is write out SOHCAHTOA. I think that's good. I think that does not go far enough. What I actually do for all of this, I write down let's take a little space here, ka, toa, like that, just because that literally makes it so makes it harder to make a mistake on this sort of problem. Okay, so I'm just looking at this, and this is just me sort of spitballing all of this, right? I look at this and I think, okay, I don't know what this angle is. I'm just going to call it X just because it makes me feel like I'm doing something in this world. And wait a second, if I call that X, then I can use one of these 3. Well, let's see. I know what this is. That's the opposite side to all of this, if I call that thing X. And I happen to know what the hypotenuse is, because that's this side. So that means I don't need cosine, because I don't have the adjacent. I don't need the tangent, because I don't have the adjacent. I have this one. So I'm actually just going to write out kind of blindly here, sine of x degrees equals, the opposite here is 1 over 4. Okay, so I'm looking at the answer choices, and I'm seeing that these things have inverse signs. Inverse signs used to throw me before I realized that they were just, the word there is that they are the opposite of it. So with the idea with, say you said like sine of 60 degrees equals 1/2. I literally am embarrassed. I can't even remember if that's true or not right now, but let's just pretend that's true. Then what you could do is just rewrite that backwards. You could say inverse sine -1 of 1/2 equals 60. That's all that an inverse sine is for that sort of thing. And now forgive me if I got this simple math fact wrong. I never was able to memorize my trigonometric tables. Okay, so this. I'm going to rewrite this now as sine -1, inverse sine, of 1/4 equals x degrees. I have no idea whether that's actually going to help me or not, because remember, I invented x degrees on here. That was not a given thing. But, I don't know, it makes me feel like I'm making some progress in the world, and some days in 2020, that's really all you can ask for, I think. Okay, so I'm seeing that. And then I'm also seeing that there's a pi in here, and there's a 45. The 45, actually, that doesn't make any sense to me, but the pi makes sense to me because, there are 2 ways of thinking about, what I was about to say is true, but let me go for a more important truth. Let's ask, what is the, what's the word here? What is the distance around, circumference, there we go. What's the circumference of this entire circle? I know there's this thing called diameter equals, wrong, called circumference equals 2 pi r, and that's great for children and other living things. But how does that help me here? So I can just take the radius of a thing and I can multiply. Oh, that's not the radius. But this is the radius right here. This 4 is the radius. And I can multiply it by 2 and then multiply it by, about 3, a bit more than 3 pi, and I can get the circumference of the entire thing. So in this situation, I'd say circumference equals 2 times pi, it's about 3, times 4. That equals 8 pi. Okay, so the distance around this entire thing is 8 pi. You're wondering, how does this help you? It's not that when I was first solving this problem, I came up with the whole full answer for how it would help me. It's that I just started doing crap. And I trusted that crap would move me toward a fuller understanding, which in turn would move me forward into feeling like I'm in a state of flow, which would in turn, and also with some duct tape and chicken wire and spit would move me toward getting the problem right. I was doing something. Okay, sorry. So I'm recognizing that the whole thing around here is 8 pi. Okay, and now I'm remembering that, hey, hold up. They want me to, in the first place, they want me to find this space right here. Okay, well, so now I can have a ratio, right? I can say that this mystery degree, which I actually happen to have a little equation for, that actually, you know what? What the hell? Let me just write in here. Inverse sine of 1/4. I bet that's actually the sort of thing that my calculator could tell me what that is, but I don't even care because I see like inverse sine of 1/4 or cosine or whatever of that in here. Oh, this is kind of fun. I bet the cosine is not going to be right. I bet this one is not going to be right, but this one's not going to be right because we're going to use sine for this rather than those other ones. Okay, sorry, ADHD problem. Okay, so sine everywhere, sine. What am I doing? Oh, that thing. Okay, so I'm recognizing right now that I can have a ratio. Remember that a ratio just in general is like, if here's a small triangle and here's a huge triangle, but there's the similar kind of triangle, then you could say like, oh, like 1 is to 14,000 as 2 is to what number? And you could set that up as a 1 is to 14,000 as 2 is to mystery, mystery, mystery. I made these numbers up and they're not even helpful numbers, and obviously none of those are right numbers. Okay, that's just a reminder of what a ratio or proportion is. I guess a proportion, maybe we call them both things. I never know. Okay, so what I can do is say that the mystery angle, I guess a faster way of saying that is x degrees. X degrees has the same relationship to going all the way around, 360 degrees, as this like mystery turn here, mystery arc, or I guess we could literally just call it arc of, was it AC? Yeah, arc of AC. Whee! I really like doing that. It's like the Amazon logo, but backwards. Is to this whole monstrous beast of a turn, a full turn, which here the distance is 8 pi. Okay, this would probably not be enough to solve it, except that, because we have an unknown right here and an unknown right here, except that, one, I probably could use my calculator to give me this unknown, and second, this unknown just literally keeps popping up in the answer choices, so I don't even need to do that. All right, so I'm just literally going to rewrite this. What color comes next in my little progression here? Instead of x degrees right here, I'm going to write down what we said x was equal to, sine, inverse sine of 1/4. Oh, I'm going to have a hard time with room here. Over 360 degrees equals, come on, AC, arc AC, over 8 pi. You know what? I didn't run out of room, which really, all things considered, was great. Okay, and now take a look at these answer choices. This, like what we have here is kind of looking like these answer choices. They want me to solve again to find the arc of AC. Don't you love all these colors? I think this is just so many colors. I like all these colors. So I basically want to solve for this right here, okay? How could I do that? I guess I just multiply both sides by this 8 pi. I'm going to rewrite this whole thing as, I'm going to use my new color now. I guess I'm up to red. Okay, AC, that arc of AC, equals, probably should have given myself some more room here. Oh, hello. Good to see you. Oh, I've never seen you in person before. Hello. Just 1 second. I'm recording a video right here. Let me pause this. Some friends just walked in.